In the last few sections, we've been looking at observational studies, but now I want us to look at how we plan an experiment. If you recall back to when we were discussing the differences between experiments and observational studies, is in an experiment, the researcher is imposing some treatment and assigning individuals to the different treatment groups. So I want you to consider an experiment on tortilla chips. There are a lot of things that can affect how delicious a tortilla chip is. Things like how long it was cooked, what type of oil it was cooked in, how much moisture there was, all sorts of different factors. So in an experiment, you would want to ask a question like, what happens when? Or what is the effect of? So here, if we were trying to fry these tortilla chips, then we would want to set up an experiment to try to make the crispiest, tastiest tortilla chips. Well, we would want to make sure that we isolated just one factor and kept everything else the same. So maybe we would have the same temperature oil with the same length of time, but we were changing the type of tortilla used. And so here we would take one type of tortilla and we would fry it in the same oil for the same time at the same temperature. Then we would take a different tortilla and do the same thing. Then when we made a comparison, we could see if the type of tortilla made a difference on the taste of the chip. Or maybe we wanted to see if the time that the tortilla chip was cooked would make a difference. So here we could take one batch of chips and fry them for 30 seconds, another batch for 45 seconds, and then a third batch for 60 seconds, and then compare the properties of the tortilla chips. But even in something that seems so simple as these experiments, we still have to make sure that everything else is held constant. Even little things like variability within the different tortillas could affect our outcome. Or maybe small changes in the temperature in the oil could change the outcome of the experiment. So we want to consider any chance-like variability that's going to happen in whatever we're studying. So in this case, the moisture content of the chips. Even if you're frying chips for the same amount of time, there still could be some variability that just happens by chance. So in order to make an appropriate comparison, in order to make the best comparison between the different experimental groups, you want to make sure that you can account for all of this chance-like variability. So what we're going to want to be looking at for this section is mostly looking at a simple comparative experiment. Now, if any of you go on to study additional experimental methods, then there are several different ones that we can consider, but we're going to keep it pretty simple in this class. So starting with a simple comparative experiment, you're taking the value of a response variable, which in our tortilla chip example would be maybe the moisture content, and then we were measuring that under different experimental conditions. So, for example, the frying time was changing. So these experimental conditions, we often will call them treatments, and the experimental condition and treatments, we can use those words interchangeably. We will have what's called an experimental unit, which is the smallest unit to which a treatment is applied. So that would be like your individual people in the study or the individual tortilla chips that you're including in the experiment. The design of your experiment is that overall plan that you're using for conducting an experiment. And we'll see in this section that there's several things that we have to account for in order to design a good experiment. A good experimental design is going to make it possible to obtain unambiguous answers to questions that the experiment was designed to answer. If you can't end up with an unambiguous answer, then your experiment isn't going to be very good. So when you're designing this experiment, you want to make sure that you can distinguish between any variability in that response that's attributable to the differing experimental conditions or the treatments that you employed versus variability that's just due to other sources. And we'll talk about that a little bit more in this section. When you're designing your experiment, you need to make sure that there are no systematic sources of variation in the response that you can't isolate. And it can be kind of difficult to figure out where some of these variations are coming from. But the more that you can keep constant in an experiment, the less chance that you'll have some of these systematic sources of variability. So when you cannot distinguish between the effects of two variables on the response, the two variables are going to be what's called confounded. Some things that are confounded variables would be things like test scores and IQ. It's hard to differentiate between the reason that you scored well on a test based on some treatment group that you were in and just the IQ that you had going into the test. There are lots of other examples of confounded variables that you'll find in the textbook.